So kind of look and compare to the notes you took. Is there anything that you want to add or anything that you want to highlight there for average rate of change? You know, if there was one thing I could have you take away from average rate of change today, if you see it again on a quiz, on a test, in another class, which you will see it in calculus, it's this, oops. How about this? Is this word, slope. Hopefully, as you were reading through page 54 and you kind of like examined the example and looked at the formula, this is the formula for slope. Who gave me that slope formula in our warm-up today? Was that Brody? Brody gave us the slope formula today. He said the change in y over to change in x. That's on my notes. Or you could write down any one of these, the slope formula, y1 minus y2 over x1 minus x2. Okay. Average rate of change and slope are essentially synonymous. Now the big difference in this section is it's not a line anymore. So like if it were a line, it would have one slope, a constant slope, and the slope would work for the whole entire line. Look at the image that was presented in the textbook. This curve or nonlinear function has different slopes at different parts. Imagine that's a hill you're walking on. Some parts are going to be easier, some are going to be harder based on the steepness of your slope. So average rate of change is just saying between 2 points. So suppose I take these 2 points right here, calculate the slope in between them. And we recognize that whatever the slope of this red line is, it's not the slope all on that curve, right? Even on this curve, there's somewhere it would be negative slope, and when I calculate, I'm going to be positive, but it's the average of all of the points. If we're thinking ahead to calculus, average rate of change is going to be this. You're going to take 2 points on a nonlinear graph, so some kind of curve, it's not a straight line. As you move those 2 points closer and closer together, your average rate of change gets more and more accurate, more and more descriptive to the curve, okay? Until you're at a single point and you're finding the slope at a single point. In calculus, it's called a derivative. We're not going to be doing that in pre-calculus, so we always have these 2 points on the curve. Okay? So we're just finding the average rate of change between them. Note that if I picked this point right here and then I picked a point closer to that point, it's more likely in this case that my average rate of change will be similar to the slopes at all the points. Okay? It won't be exact for all of them because it was curved, but it'll be closer. And then you also should have some kind of formula in your notes or some kind of statement about how you're calculating average rate of change, but also the fact that it's a slope should be your big indicator, change in y's over change in x's. The formula they give you in your pre-calculus textbook may look a little scary because they're using function notation here, but f of x sub 2 is just a fancy way to write y sub 2. So this is also like right here, this is just saying y sub 2 minus y sub 1. So then that goes back to that slope formula you knew in Algebra 1. I always tell my students f of x is a fancy way to write y. So it doesn't mean any like f times x or anything. It's just a substitution for y. Okay, so let's do one example. This will be similar to your homework assignment this evening for the weekend, which is 2 problems. I don't know if you can handle it, but I think you can. Plus, you have to take another set of notes on page 55. So I think it's pretty reasonable so far. Okay, find the average rate of change for this function from x sub 1 equals negative 2 to x sub 2 equals negative 1. You know, in setting yourself up for success in this class, as you're taking quizzes, as you're taking tests, you have to be able to read the directions and know what it's asking. So when you see find the average rate of change, I'm hoping you think about slope. And like Brody told us, the slope is change in y over change in x. Okay. If you want to memorize the formula they gave you for average rate of change, I'm going to use ARC for that. That's f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. So if we have those four things, then we can calculate the average rate of change, that slope. I look at my problem. I already know x sub 1 and x sub 2. I just need to find what? The y values. If you know x and you're given a function, substitution, and you'll find y. So f of x sub 1 is really f of negative 2, because that's what I'm told x sub 1 is. And then I'm just subbing it in for these x's right here. So that's negative 2 cubed minus 3 times negative 2. What is that? Negative 8 plus 6. So negative 2. And then I would do the same thing for f of x sub 2, which is really f of negative 1. Make the substitution. Minus 3 times negative 1. That's going to be negative 1 plus 3, so positive 2. So I'm just plugging in to find the y value. It's different than our warm-up example where I gave you xy ordered pairs. In this case, I'm giving you x values and a function, so you have to calculate the y value from that. But then you make a substitution. So we're going to do 2 minus negative 2 over what? Negative 1 minus negative 2. So 4 over 1, which is just 4. There's your average rate of change. You know, what I'm imagining from that is I should be seeing, like, on this nonlinear graph, which is a cubic polynomial, that it must be increasing for most of that. And it's probably pretty steep because my average rate of change is 4. So in some places it might be higher than that, and in some places it could be a little bit lower, but it averages out to 4, so it's probably a pretty steep part of the curve. Any clarifications you would like on that example? Do not overthink it. Calculate slope. Okay. Your homework assignment for the weekend is page 57, number 62, 63, and another read, review, and take notes. So, you know, this stuff, even in odd functions, we are going to cover on Monday. If you would like to put that, like, after your average rate of change notes in your notebook, you know, put it in where your notes are going to be. It doesn't need to be with your assignments if you've got separate notebooks for that. So, you know, when I give notes on Monday, if you already have information about even odd functions, you might not have to write everything that I put on the board down because you've already got it. And then I'm going to pass out the 8 basic function sheet here.